So today we're going to be looking at vector subtraction, and again, when you talk vector subtraction with components, remember how frustrating vector subtraction was last year? Remember that? It's frustrating for me too, because it's one of those crazy concepts where we really make it harder than it should be. But to sort of set it up properly, if I just sort of taught you how to do it quick and dirty, it really wouldn't be vector subtraction. Okay? And I think it leads better into this. I think this is a lot easier in grade 12 simply because of the way I set it up in grade 11. At least that's what I tell myself so I can sleep at night. So it's on page 105 if you want to follow along the book. Once again, the book probably does a way more complicated job than I do, so I try to clean that up a little bit. Yeah, starting here on the bottom of page 105. So the book likes to deal with, I'll just point this out here just so you can thank me, about 5/6 of the way down the page there, right at the bottom of the page 105. Can you see that VPA equals VPG minus VAG? See all that crazy subscript stuff going on there? It's like, I don't even know what they're talking about, kind of, right? Come on, yeah, thanks. So I'm going to make that a little bit simpler for you. So we already know, probably from grade 11, that suppose we're talking about a plane in the wind. So the resultant vector is the plane vector plus the wind vector, right? Here's the plane heads straight north. Here's the wind, it's heading straight east. The overall resultant vector is like that, right? I think everyone in the room should get that, no problem, right? And I do a little of this in grade 11 as well. So rearrange to solve for P or W. The plane vector, all you do, if you take this and sort of, rearrange for P, then the resultant is, the plane vector is the resultant minus the wind, or the wind vector is the resultant minus the plane vector. Does that make sense? Just from a pure sort of arithmetic formula, symbol manipulation standpoint. I'm getting a few kind of nods, but I'm not real sure. Yeah? I need that feedback, guys, that I know. Yeah, you're okay with it though, Peyton? Okay. So this means vector subtraction when trying to find the wind or the plane speed. I mean, that's what it boils down to, right? I should probably have the word wind here. Okay. It's going to be vector subtraction when you're trying to find the plane or the wind speed. Why? Because the plane and the wind speed, you can think about it this way. What are the components of the result? What are the two things that make up the result? The plane and the wind. If you think about it from a pure component standpoint, if I just call this vector V, and call this vector Vy component and vector Vx component, what are the components of the vector? Vx and Vy. What are the components of the result? P and W. Okay, so if you're trying to find one of the components, because of this, you're going to be doing subtraction. And vector subtraction, the arithmetic behind it is super simple. To subtract vectors by components, simply subtract rather than add. That's really what it boils down to. Simply subtract rather than add. Let's do a real simple, completely generic, non-situational based vector subtraction question. Suppose we got a situation like this, and I'll give you a second to jot down those numbers. All right, so let's just have a look here and see what happens. So I've got A, I'm supposed to go A minus B, right? So A is that, and B is that. If you've got it on your paper, certainly you don't need to write it down again. Break A again into components, X and Y component. So A is 12 whatevers at east 26 south. East, 26 degrees to the south. There's my AX, there's my AY. AX is 12 cos 26. Why is it cos? Because the X is adjacent. And why is the Y the sign? Because the Y is opposite the angle. So calculate your AX and your AY. Do I have those? No, I don't. That's weird. Well, times cos 26. I get 10.8. .3, I guess. pause there and see if anyone can spot the mistake that I made. What's the mistake, Chris? Which one? The AY should be negative. Why? Because it's down. Exactly. Now, be careful, vector subtraction and negative, right? Like, don't rush through this. Just, take a moment, make sure you got it right. Okay, let's do this exactly the same thing for the V. V is east 14 north. So we're looking at east 14 degrees to the north. So 8 cos 14, 8 sine 14. 8 times cos 14. 7.8. 8 sine 14. 1.9. Both positive because it's to the right and up. So we should be fine there. Okay, so now, both positives, I think I went through that already. Now we simply do the subtraction. Cx is equal to ax minus bx. Cy is equal to ay minus, yeah, that's right, ay. No, that should be what? That one's wrong right there, right? I got to do subtraction here. What do I have on the next page? Do I have the subtraction? No, I don't. Okay, so let's just finish this off here. So Cx is simply going to equal what? It's going to be Ax, which is going to be 10.8, and I'm going to subtract Bx, which is 7.8, and doesn't that work out nice? It's 3. And Cy is equal to Ay minus By, which is going to be minus 5.3. Subtract By, which is 1.9, and I'm afraid I'm going to have to... No, I can probably do that. I can probably do that. What is it? Minus 7.2. What's the next step, Peyton, now? You don't know? Anyone want to help her out? What's the next step to solving this? I said you didn't have to do this, but I also highly recommended you do this next step. What's the next step? Put them together. I highly recommend drawing a picture. Right? So the x is 3. The y is 7.2, which is going to be down. So let's see if I can move. No, I can't. So the cy is minus 7.2. So this is 3. This is 7.2. Do I need to put the negative sign in there? It's optional. I mean, it just indicates down, right? So then this is my, I guess it's vector c here, right? So you would have c squared is equal to 3 squared plus 7.2 squared. You guys can do the math.
Thanks.
7.8. And of course, we're not done. We've got to have that angle there. So theta is equal to the inverse tan of 7.2 all over 3. 7.8, thank you. Did you just do the switch in the book too? I have some thoughts. Dallas is asking why I put positive 7.2 there or there. Couple reasons. Would it matter to the arithmetic, Dallas, if I did this? Because it's just squared, right? So minus 7.2 squared is going to be the same thing, right? The negative, you got to get it out of your mind that the negative, I hate doing this to you. Sometimes the negative is important, sometimes it isn't. And once you get to that point, it's no longer important. Because the negative, all it does is imply or show that it's down. Did I?
Yeah, 7.8 divided by 3 is 2.6, not the...
Oh, yeah. It did seem wrong. Miss Agnew walked in and I got a little distracted there. Having another conversation with something else. So 7.8 divided by 3, and then I got to take the second function tan of that, right? Thank you, Paige. So we got 69 degrees, is that right?
Yeah.
Okay, and that's going to be east 69 south. Did I answer your question, do you think, Dallas? Like, if you put the negative in there, is it going to make any difference? No. By all means, if that makes you feel better and that's what you need to make sense of things, you go right ahead and do it. It's not going to matter. Jason, you look like you want to say something. Yes, it should. Peyton. Because you're the one that said I messed up there, but you missed. I know. Is it okay to make mistakes? Yeah. Yes, it is. As long as you? Yeah? Do you feel like you've lost trust in me, Brandy? You can't trust me to know what I'm doing up here? Yeah, you know what? It's all just a big figment of your imagination. I've made this up completely. No other physics teacher in the world is teaching it this way. I just made this stuff up.
You made up physics.
So really, like vector subtraction, is there any difference at all? All you do is subtract. The only difference is right in there. That's it. Same concept, right? Wow, that's easy. Why didn't you do that last year, Mr. Bennett? A jerk. There's a few questions on page 116 you can try. What I'll do tomorrow is we'll do relative motion. That doesn't mean your aunt and uncle coming for a visit. Thank you. And once that's done, like I said, that's about a 45-minute kind of deal. You will need textbooks tomorrow because I do use the textbook for that. And then I'll give you the rest of this period. I'm going to give you probably a good portion of tomorrow, half a period or so. Thursday, you'll get, and then we'll have the test on Friday. Hopefully the fire drill will have happened by then. We won't get interrupted.